Hello students, this is a lesson on factoring polynomials. Depending on whether you had Math 2 in the fall or in the spring last year, you are going to be at varying levels of knowledge on this subject. So I'm just going to kind of start at the beginning with factoring quadratics and move on into some of the Math 3 stuff. You are really going to need to know how to do this for our next unit. When we start doing rational functions, you've got to know how to factor your polynomials in order to simplify the function and graph it, or look at the properties or whatever. So it is important that you get this lesson and that you understand it. The classwork for this is not going to be a PDF. It's actually going to be on thatquiz.org, which I don't know if you remember way back at the beginning of the semester we did some work on thatquiz.org, and it's one of those things where you'll know if you got it right as you're doing it. Now, I will do a classwork help video for that assignment. So let's get started. There are right many problems on here, and this is kind of a weird PDF. It's different from what we're used to looking at because it's just problem after problem. But I think this is the best way for us to have enough room to work, and really the best way to go through this kind of thing is just to go through problems. So when we talk about factors, those are actually the zeros of a function. So we can talk about this is a polynomial, but it's also a function. And so if we were to graph this, we could see that there are two real factors, or two real zeros, or x-intercepts. And if you remember that, and I talked about this in the division videos, but the x-intercepts, zeros, and what we call roots, they're all equal to each other. They mean exactly the same thing. Now, if an x-intercept or a zero or a root is, let's say, at -3, then that factor is x plus 3 in parentheses. And so what we're trying to do is we're trying to find the factors, or the roots or the zeros or whatever, to this polynomial here, x squared minus 4x minus 12. Now that's all just kind of an introduction. Let's talk about how you actually do that. Sometimes you'll be given just the polynomial and it says factor this. And other times you'll, back like when we were doing the synthetic division and the long division, I talked about the fact that, they might say something like, is x minus 2 a factor of this? And then you can use division and figure out whether it is or not. If we're just factoring a trinomial, this is called a trinomial. You can also, it's also called, so this is a trinomial, and I can't spell today. Trinomial. So this is like the fourth video I've done today. So my brain is kind of fried. Trinomial. Okay, it's either called a trinomial, or you also might hear it called a quadratic. A quadratic is just a polynomial with an x squared term. Okay, a trinomial means it has 3 terms, if you remember back from last week when we were talking about polynomials. But this is a quadratic trinomial, and here's how we do it. So we need to look at 2 different numbers. We're going to look at our constant term, which is -12, and we're going to look at our middle term, which is -4, just the coefficient, okay? And what we need to do is we need to find what we call a factor pair, which a factor pair is just 2 numbers that you multiply together to get a number, okay? So I need a factor pair for -12 that when I add it together, or when I combine, I get -4. So what I can do is, because this is not a very big number, the -12 is not a great big number, I can just sort of think to myself, okay, what are factor pairs for -12? But I need to think, okay, one of the numbers has to be negative, one has to be positive. So factor pairs for -12 would be 1 times -12, 2 times -6, 3 times -4, and then I could switch all the negatives too. I could say -1 times 12, -2 times 6, negative 3 times 4. So what I need to do is look at all these pairs of numbers and put a plus sign between them. And then whichever one adds up to negative 4, that is the pair that I need. Okay, so when I look at these, the first one I come to, 2 plus negative 6. Well, 2 plus negative 6 does equal negative 4. So 2 and negative 6 are the numbers that I'm looking for. Well, I'm going to factor this thing into two binomials. Binomials, if you remember, has two terms. So it's going to be two sets of parentheses, and you might remember doing this, an x in each one, and then these two numbers are going to be what the other part is. So I've got a plus 2 and a minus 6. And if I were to go back through and multiply this out, use box method or use FOIL or whatever it is that you want to use, I would end up with this right here. But this is my answer. This is my answer when they ask me to factor. Okay. So that means the factors of that polynomial are x plus 2 and x minus 6. That means the roots, or the zeros, or the x-intercepts, are at negative 2 and 6. Okay, so all that was in just that one problem. But you know, when you're doing math 2, it's like, okay, factor it, here's how you factor it, whatever. But when you get into math 3 and you're talking about all the functions and everything, you need to understand, okay, this means these two things are the factors and these are the roots. And if I were to graph this thing, it would be a parabola. It would open up, the a value is positive. It would open up and I would have roots at negative 2 and at 6. So it would look something like this. Okay, so that's a little bit, we get a little bit further into it in math 2 and then more in math 4. I'm sorry, math 3 and more in math 4. All right, let's look at another one. Let's talk about factoring this one. Okay, so I need a factor pair for negative 72. And if you get bigger numbers and you need to use a calculator, I can show you how to use a calculator to get the factor pairs. But 72, we can kind of think about what they would be. I need it to multiply to get 72, and I need it to, negative 72. I need it to combine to get 6. Let me get a different color. All right, so let's think about some factor pairs for negative 72. So, of course, there's 1 times negative 72. We know that doesn't work. 2 times negative 36. That won't work either. 3 does go into it, but I'm not going to really worry about that because I know that won't work either. I'm thinking, let's see. 9 times 8 won't work. I need it to be a difference of 6. How about 12 times 6? And if I put a plus sign in between the 12 and the negative 6, that does equal 6. So 12 plus negative 6 does equal 6. So that's the pair that I needed right there. Okay, so then my factors are r plus 12 and r minus 6. So this means that the factors for this polynomial function are r plus 12 and r minus 6. That means the roots are negative 12 and 6. I hesitate putting a comma between those. I don't want it to look like an ordered pair. Let me show you how you can find the factor pairs for 72, actually for negative 72, using your graphing calculator. Let's do, let me clear this. So if you go to the y equals button, and then you type in the negative 72, and then divided by, and then the x button's right here, x, okay? And then hit second graph. It's going to give you a table. And I don't know if you can see this very well. I don't think I can make I can make it a little bit bigger. That's good. Okay, so what it's going to give you is it's going to give you a bunch of numbers that this times this equals 72, this times this equals 72. You want to look for the whole numbers, though, the integers. You don't want to look for the ones with the decimals in them. So 4 times negative 18, 6 times negative 12, and then you keep going down, 8 times negative 9, keep going, and here we have a 12 times negative 6. So what you're looking for is you're looking for something that when you add it together, you get positive 6. So that was the one that we found would work. But if you're not sure about the factor pairs for a particular number, you can use your graphing calculator. So let me go through those steps one more time. You would go to y equals, and then whatever number you want to put in there. Let's say we have 684. 684, okay, divided by x, and then go to second graph, and it's going to give you a table of all the numbers that that when you multiply the pairs of numbers, you get 684, and then you can go through your your down arrow and go to all of them. But you only want to look at the ones that are whole numbers, like the 36 times 19, the 38 times 18. Don't look at the ones that have decimals because that doesn't matter. So that's how you do that if you need it. I don't think any of the ones we have here today are going to be, the numbers are going to be that big. Okay, so I think that's all I have. All right, so the ones that we did so far, what we had were we had the x squared or the r squared terms. This term right here has a 1 coefficient, okay? So the a value is 1. So that's what we call the a value. So the a value for this is 1. So it's really easy to do these if your a value is 1. You just look for the factor pair for this that adds up to this. That's it. I'm sorry, y'all can't see what I'm pointing to. The factor pair for that adds up to that. But if your a value is not 1, there's a little bit more involved. So here we have a 2. In fact, I'm going to highlight that instead. So if your a value is not 1, if it's greater than 1, you have to go through a little bit more to make this work. And there are some little tricks that you can use or whatever. I tend not to use those tricks. I would rather show you how it works and show you the steps than to show you, oh, use this magic X or this, or this this method or that method, or there's something called slide and divide, I think. I don't even know how you do it, but anyway. So the main thing that we need to understand is that this middle term right here, and that's a 1 right there in front of the P. Let me get rid of this. Oh, that's not an eraser. I thought it was my eraser. Get rid of that. So the middle term is kind of what I'm focused on. This positive 1 right here. That number is going to end up being split into 2 numbers. Okay. So what we're going to do is the first thing we want to do is rewrite this polynomial. And we're going to end up putting 2 numbers in there. And I don't know whether it's going to be plus or minus yet, so we're going to leave that blank. And then this is going to be a minus 6 right here. Okay. So we're going to end up splitting that 1p, into something here and something here. So we're going to come back to that. So here's our steps. The first thing, the next thing we need to do is multiply our leading coefficient times this number right here. So 2 times negative 6 is negative 12. Okay. So then we're going to find a factor pair for this that adds up to 1, just like we were doing before. Okay. So same steps we would use for the a equals 1 quadratic. So we have the factor pair. I mean, we've multiplied these together and we got negative 12. So I need a factor pair for negative 12 that when I combine, I get this 1 right here in the middle. Okay, so let's think about factor pairs for negative 12. I'm thinking 3 and 4. One has to be negative, one has to be positive for it to be a negative. So it's going to be negative 3 times positive 4, right? And that would give me 1. Negative 3 plus 4 would equal that 1 right there that I need. Those are the numbers that are going to go in these red clouds right here that I have over here. So minus 3 and plus 4. So look at that. I rewrote the original quadratic, but what I did was I did what we call split the middle term. Okay, so that's the first thing we need to figure out how to do is split the middle term. And to split the middle term, I got to figure out what to split it into. And that's why I multiply the 2 times a -6, got -12, and then I need to know what the pair of numbers is going to be right here. So I got to split the middle term. The second thing I do is I group the, let's say, oh, I'm sorry, I should have put a p in there. It's 3p plus, -3p plus 4p. That equals 1p. So now what I need to do is I need to group the pairs of terms. And what I mean by that is put parentheses here and here. The third thing I need to do is factor out the greatest common factor. Okay. Now we haven't really done any of that yet, but like I said, this is supposed to be a review for you guys. So factoring out the greatest common factor of each of the pairs. We'll say of each pair. So 2p squared minus 3p. Well, 2 and 3 don't have any factors in common, but p squared and p, they have a p in common. So I'm going to factor that out. So what I'm doing, remember, is the opposite of distributive property. So what I'm going to do is factor out the p, and then I'm going to divide 2p squared by p, that's 2p, and minus 3p divided by p is 3. So let's go make it a different color. 2p squared is like 2p times p divided by p. Those cancel, so it's 2p. That's why that 2p goes there. And then plus, now 4p minus 6, I need to factor that. 4 and 6, or -6, have a factor of 2 in common. 4p divided by 2 is 2p, and -6 divided by 2 is -3. Okay, so here's what we're looking for. Let me erase this part right here. Let me get a more highlighter. This and this, the two things that are in parentheses, if they match, you did it right. If they don't, something's not right. So what's highlighted, we're almost done, is my first factor. So my first factor is the highlighted part, and I only need to write it once. 2p minus 3. And so once I write that, it's kind of like taking the greatest common factor out of that. But once I write that, what's left over is my second factor. And I know this is a lot, especially if you haven't seen it before. But oops, that's my box highlighter. That's fine. That is my second factor right there, p plus 2. So then I make another set of parentheses, and I put that in the parentheses. Okay, so factor out of GCF. The first factor is in parentheses. And second factor, whoops, 5. Second factor is what's left over. Now we're going to do another one. Let me see what else I've got, because this is another one. Let me see if I've got another one. Okay, let's skip down to number 5. Let's mark this one out. We're going to run out of time. I'm already at 20 minutes. Mark this one out. Okay, skip down to number 5. I might not have time to do all this, or I might just have to abbreviate this. Okay, so we need to split the middle term. So we're going to split the 13x into something plus something or something minus something. To do that, we're going to multiply the 2 times a -15 You know what, I'm not going to write that part. I think that's a little bit confusing. You're going to multiply the 2 times the negative 15. That's negative 30. I need a factor pair for negative 30 that will give me positive 13. What times what equals negative 30 and also equals positive 13? Well, that would be a 15 times a negative 2, or plus a negative 2. So this is what I'm going to split it into, 15x minus 2x. So when I rewrite my original, which I should have done in the first place, I'm going to bring this here and this right here. And that equals 13x. So I split my middle term. Now I need to make parentheses. Now I need to take the greatest common factor from each binomial. 2x squared and 15x. The only thing I can take out is an x. That's going to be 2x plus 15. Okay, so right here, I can't take out anything because there's nothing that these two terms have in common, but I can take out a negative 1. 2x divided by negative 1, sorry, negative 2x divided by negative 1 is x, and then negative 15 divided by negative 1 is 15. I'm sorry, 2x, sorry. So I just actually left it the way it was. So now I've got this matches this. So that's my first factor. All right, so that is when quadratics have an a value that is greater than 1. The other ones that we did were a equals 1. Here's another one. I'll try to do this one kind of fast. I might go about 30 minutes on this today, guys. Sorry. Okay, so I'm going to be rewriting this whole thing. I already know these are both going to be plus. Okay, so I rewrote it, and I need to split the 14x into something here and something here that adds up to 14. 5 times 8 is 40. Oops. 40. And I need it to add up to 14. What times what equals 40, that when you add them together, they equal 14. It's going to be 4x and 10x. All right, so I made the 14x 4x plus 10x. Parentheses. Greatest common factor. Right here, it's just an x. 5x plus 4. Over here, it's going to be a 2. 5x plus 4. So I did it right. These are the same. That's my first factor. And x plus 2 is my second factor. All right, so another way you might see it, like I said before, is where they say, if x minus 3 is a factor of this, what is the other factor? Well, we can use synthetic division. We can divide 3, or the root of 3. That's a 1, and a negative 12. Bring down the 1. It's 3, 4, 12, 0. That's the remainder. So this is the constant, and this is the x value. The other factor would be x plus 4. Skip number 8. Okay, so this one right here, one thing you always do want to look for is the greatest common factor that you can pull out. Every single one of these things can be divided by 5x. So if I took out a 5x, I would have x squared minus 4x minus 5. And then I can factor this part, just leave the 5x. You know, it's going to be 2 binomials. -5 factor pair that adds up to -4. That's going to be -5 times 1. So x minus 5, x plus 1. Okay, let's see. Another one where we could take out a greatest common factor of 3x, and then we would end up with, that's going to be 6x squared minus x minus 1. And then we have to factor this part. I can show you a trick, because I know that this doesn't need, I don't think this needs quadratic formula. Let's go over to Desmos. I'm trying to save time here. So like I said, these are functions, okay? So you can always type in the equation and you can find the factors. Let me show you. Okay, so you don't really have to put in f of x on one like this, but you can. Okay, 6x squared minus x minus 1. Okay, so there's that graph right there. Okay, where are the x-intercepts? The x-intercepts are at negative, that's negative 1/3. Let me show you that. Negative 1/3 and 1/2. Okay? So let me go back over here. X-intercepts are at negative 1/3 and 1/2, which means the factors would be x plus 1/3, which I wouldn't want to factor that anyway, and x minus 1/2. So this thing factored is that. We could have actually done the same thing with some of these other ones. We could have gone and typed in this one and this one. We could have done any of these because none of these have what we call imaginary roots or anything. So let me see if there's anything else I want y'all to do right now. Let's see what this one looks like on Desmos. (3x cubed minus 2x squared minus 3x plus 2. Let's see. Yeah, we can do this one. So that right there is 2/3. Okay, this is a whole lot easier. So then here's our x-intercepts, or our roots, which are, you know, where it crosses the x-axis, are -1. That's 2/3. We'll just write it as 2/3 instead of that decimal. And 1. Okay, so if my roots are here, then what goes in my factors, and this is going to have 3 factors, and that's all those things are. That they have to do with the x-intercepts, is x plus 1 for this one, x minus 2/3 for this one, and x minus 1 for this one. That's the answer right there. It's kind of easier, but the problem is when you have to use quadratic formula and you have imaginary numbers that are roots, which we're actually going to talk about some tomorrow. So let's see, what else I think we're going to skip those. I can do these when we do quadratic formula. So you can mark out numbers 12 and 13. And then, like I said, I will do a video for the classwork, but the classwork is going to be online. I don't want to do IXL because sometimes they throw stuff in there that I'm not prepared for you to see yet. So we're going to do a that quiz assignment, and I'll do a help video for that.